Using 3 ordinary 6-inch nails to demonstrate corrosion and computerization of cathodic protection. The setup is, as usual, we have 3 nails. The charges are going into, one moment, the charges are going into this nail. They will then go into the electrolyte, into this part of this nail, which is a foreign pipeline. They will come out of this part of this nail and into this nail, which is a protected pipe. So this is a cathodic protection system, but it is also a corrosion cell. It is forced corrosion by the 6 volts that is of energy in here, which is being drawn from the pipeline and pumped into the anode. Now you will notice there is no reading on the meter at the moment. I have connected the, reset this. This is dry. Now, we often get dry circumstances on pipeline surveys, and that is, we get no reading because the connection between the meter and the measuring circuit has got so much resistance that the readings on the meter are fluctuating. They are meaningless. Now, what we do on a pipeline is we add water. And the reason we add water is to improve the contact with the ground of the probes that we are using in the survey. It doesn't have an effect on the pipeline itself, but in this case, it will have an effect on the pipeline itself, because even though we wet the ground where the probes are, you can see that the moisture is beginning to travel through the whole of the circuit. Charges have started to flow from the anode through the electrolyte, and because the resistance of this metal is much less than the resistance of this electrolyte, the charges will pass onto the metal here and from the metal there. This is because the potential of this electrolyte here is higher than the potential of the electrolyte there. charges flow from a higher potential to a lower potential. We are draining the current from this nail, and therefore the charges available in the electrolyte in this area are much, much less than the charges available here. So the charges flow out of here and onto there through the electrolyte. Now I will remove the probe from the pipeline and put it onto the electrolyte. So this is electrolyte to electrolyte potential difference. And this is how we can actually computerize cathodic protection. Because by putting one probe in a fixed position, we can actually plot the potential of the ground in steps in a pattern that can be mapped on a computer to show the disposition of the charges in the electrolyte. And you can see the little marks that are being made here. And you can see the readings that are changing. And a data logger can record these readings in this pattern. Oops. And we then have a computer model on which we can make calculations using Ohm's law and Kirchhoff's law to define the disposition of the charges in our cathodic protection system. So that is how we map it. And this goes straight into a computer. And this can be used as a data logger. So we will log that and we will put this into Excel and we will make the straight lines of the graph, we will fold them to make a picture which Excel can make into a three-dimensional graph, as I've shown on many of my publications.